Hello there everyone, good morning. I'm Stuart, just in case we haven't met before. Okay, I'm Stuart, the ExamSolutions guy, and I'll be doing this live stream this morning with the help of my colleague Michael, who is online. He's going to be answering the questions in the live chat that you put up from here on. Okay, so Michael's from Air Maths Tuition, and yesterday, if you were on when we did the pure maths workout, I mentioned that Michael is going to be doing some presentations next week. On Monday, Wednesday and Friday, he's going to be doing some GCSE presentations. So if you've got a brother, sister who's doing GCSE and is around, I'm sure it'll be good, and look forward to hearing those live streams. Okay, so right, okay, I can see as usual a lot of the regulars back. Welcome back, and hopefully there's a few new people out there. And yeah, what are we going to be doing today? It's statistics, and I'm going to be looking at some exam questions, and there's three of them. We're going to be covering, let's think, normal distribution. We're going to be looking at set theory, bit of probability in that, and if time allows, we'll be doing a permutations question. Okay, all these questions taken from different papers. And I've picked them because I believe that they'll give you some tips on the way as well. Okay, so this is aimed at AS A-level. Okay, so that should be that. Okay, now before we came on, I don't know if some of you saw it, I was asking you to draw me a line of 5 centimeters. So if you haven't done that, just grab a scrap of paper, and I just want you to draw me a line of 5 centimeters, okay? And I'll just bring this up here, okay? So there we go. Might seem an unusual thing to ask you, but can you draw a line which is 5 centimeters long? Just let us know when you've done that. Just type in done, okay, and it'll be good to see how many of you are taking part in this, okay. Just type done when you've drawn me a line which is 5 centimeters long. Okay, yeah, we've got a few people coming in with done. Okay, this is to draw a line that's 5 centimeters long. Okay, right. Okay, good. Okay, so what about this one, number 2 here? What about drawing a line that's 5.02 centimeters long? Just let us know when you have done that, okay? Just put done again if you've done that, okay? 5.02 centimeters. Okay, a few thumbs up there for done by the looks of it. Okay. Right, it shouldn't take you too long really to figure this one out. Okay, 5.02 centimeters. Okay, we're going to do this one. Okay, let's try this one. Can you draw me this one? Okay, a lot of dones. Okay, coming through. What about number 3? This length here, 4.928136 centimeters long. How about that one? Okay, let us know if you've done that one. Some of you seem to be taking a little bit of time on this one. Yeah. All right. What about this one then? Number 4, this line here. All right. Okay. It's getting tricky, is it? Right. Okay. Well, the answer is that it's interesting to see that all of you said you could draw a line that was 5 centimeters long. Right? Well, I say all of you. I'm assuming that when I said done, when you said done, that you had drawn a line that was 5 centimeters long. Well, the strict answer is you can't draw a line that is 5 centimeters long. If I said to you, draw me a line that's between 4.9 centimeters and 5.1 centimeters, I'm sure you could. All right. All these other lengths, you just can't do. So why should you be able to draw a line that's 5 centimeters long? Okay, they're all generally going to look much the same if you could ever draw these lengths. It's impossible to draw a line that's 5 centimeters long. This brings me to a common point, okay, which I'm often asked, okay. We will get to some exam questions in a minute, but I just want to bring this point to you that around the variable, let's say x, to be the random variable, rv for short, the length of the line in centimeters, and I would expect that length of the line that you would draw would be distributed normally. With a mean of 5 centimeters, you draw around about 5 centimeters, but there will be a variance given by sigma squared. Sigma, remember, is the standard deviation, and these are the two parameters that describe a distribution. So if you were to draw a normal distribution graph, it would be centered around the 5 centimeters. And then you would have a chance of drawing a line that was somewhere between 4.9 and 5.1 centimeters. It would be given by this area here. Remember, the area of a normal distribution graph totals 1. So this, you'd have a fair chance of drawing a line between 4.9 and 5.1 centimeters. So when it comes to what's the chances of drawing a 5 centimeter long line, you all said you could do it. Well, that you didn't, okay? You might think you did. The probability of drawing a 5 centimeter line is 0. And in fact, the probability of drawing any length like this is 0. But you have a chance of being able to draw within certain boundaries, okay? So, hope you were able to follow that, okay? I just thought I'd pull that stunt on you. Right, okay, let's get on with the live stream, these exam questions, because this is quite appropriate, okay? What I've got next is a question on normal distributions, and it is about lengths, okay? The length in meters of cars in a city are normally distributed with a mean mu and a standard deviation of 0.714. Probability that a random chosen car has a length of more than 3.2 meters and less than mu meters, okay, a mean mu, is 0.475. And your problem here is to find the mean mu, okay? So, away you go. All right, I'll drop a few hints on the way, or a few checks, just so that you can see that you might be making the progress in the right direction. Okay, but if you feel that you've got the mean mu, okay, give it as a decimal to 3 significant figures, say, just enter it in, okay? So I'll give you a few moments to get that going. So you should be setting up your normal distribution by now, okay? It's always good to draw, I believe, a picture, a sketch of what's going on. You might want to check this out. I have defined x to be a random variable, the length of the car in meters. You should be past this stage by now, where x is distributed normally with a mean and mu, and it has a variance of 0.714 squared. The standard deviation is 0.714. Okay, so you should be through that. You should be also by now realizing that the probability of being in this interval between 3.2 and the mean mu, that length, is equal to 0.475. I'm assuming you most probably got a calculator, by the way, that can work out normal distributions. I'm going to be showing you that as we work through this. Some of you might be using tables, okay? The 0.714 is the standard deviation. We're given that, okay? If this is new to you, Sonal. I will be going through this again. If you're a bit stuck on this, do look on my website, ExamSolutions.net, for tutorials on the normal distribution. Okay, the normal distribution, it's all there. Okay, you should have sketched a normal distribution graph, something along these kind of lines. Accurate, but just a sketch. Okay. Right, okay, we're going to keep giving you a few clues of where you should be by now. You should be marking on 3.2 on your sketch if you haven't done that already. Mean center here, 3.2 is to the left. I know that because it's saying the probability of being less than 3.2 is 0.475. Remember, the area under the whole graph is 1. The area to the left of the mean, mu, which represents the probability, is going to be half, 0.5. We've got 0.475 here, so it will be to the left of the 3.2. I'll mark that on. Okay, here it is here. Okay, you should be, whoops, okay. I was slipped there. Okay, so you should be now working out this area to the left of 3.2. Okay, you're going to need to know that, which represents the probability of being less than 3.2. Okay, remember that the area to the left of the mean mu, the probability of being less than the mean mu, is 0.5. So anybody got the probability of being less than 3.2 out there? If you want to just type that in, it would be good. Probability of being less than 3.2 at this stage. Good. Okay. Good to see those answers. 0.025. Good. Put it up there. There's the sum. Probability less than 3.2 is to subtract 0.475 from 0.5. And you could shade that in your graph there. Okay. The next stage, okay, you should be thinking about drawing a standardized graph. A standardized graph we often give as represented by the random variable z. It's a special graph. I'll put it on here. It's a special graph with a mean of 0 and a standard deviation of 1. So the variance would be 1 squared, which is 1. Okay? And you project this down onto here. Your job is to eventually work out what this z value is. If anybody's got that z value by now, just type it in. Okay? 0.5 is the probability of being less than the mean mu. So that area to the left of the mean mu is 0.5. We take the 0.475, which we were told was the probability of being less than 3. I beg your pardon, being more than 3.2, unless the mean mu is 4.475. 0.475. It's this area in here, sorry, that was 0.475. Apologies for that, okay? So I took 0.475 away from 0.5 to give me this area, the probability of being less than 3.2. Sorry for that confusion, all right? Okay, we're getting some answers in, I notice, for the final probability, for the mean, I mean, mu. Okay, so... okay. Right, sorry, answers are streaming in here. I'm getting a bit distracted. I should say I'm seeing answers for Z coming through. The answer for Z down here is minus 1.96, okay, approximately to 3SF. So that's good. We've got that. Okay, let's just keep you going. You should know this formula here, and you should sub in values for the observed value x, which was 3.2, standard deviation 0.714. You need to get your value z. Okay, and I can see some of you guys have got that value of z as being minus 1.96. Okay, so you should be substituting it in this formula to get the mean mu. All right, it's quite a difficult one, this one then. Difficult one most probably to put on a live stream. I'm going to help you out here. If you've got a calculator, something along these kind of lines. Okay, let's just bring it up on the screen now, okay. You should, this is a Casio Class Whiz calculator. It's an emulator here. If you've got a calculator like this, what you've got to do is put it in statistics mode by pressing the setup, the menu button here. Go to 7, which is the statistics distributions. So just enter 7. You should get a display like this. You're looking for the inverse normal distribution. Okay, so we can work out what Z is. So it's given by the menu item 3. It'll bring up this menu. You type in the area. Okay, the area that you're looking for here is 0.025. Okay, so we can put 0.025 in the calculator. Sigma, the standard deviation, is 1. Okay, the mean is 0. So this is already set up for that. If we press equals, we can get our Z value. Okay, this Z value would it be expected to be a negative value. So you can see it turns out to be minus 1.9599 and so on. So there's your Z value. Okay, we'll bring it up on the screen here. And you should be almost there now. Okay, if we take the calculator off. Okay, all you've got to do now is to go back into the formula for Z down here, substitute your value in for Z and rearrange, and you should get the mean mu. I see some of you have worked ahead here, and well done for getting that mean at 4.6. It looks like Iggy got that one first. Okay, so let's just take you through this last bit. Substitute this into here then, okay, and you should get your equation here. You just need to rearrange it, okay, and if you rearrange it to find the mean mu, okay, you should get this, work it out, and bang, out comes your answer of a mean of 4.60 to 3 significant figures, okay, our value here. Right, okay, I don't know whether that worked too well for you guys out there, but doing statistics live is quite tricky, but well done for doing that. taking part on that one as well. Okay, so we're just going to move on now to the next question. Someone asked for some Venn diagram, set theory, probability. That's what I'm going to put up next. Okay, so hopefully you'll find this a little bit easier. Here it is here. Okay, there's several parts to this question. I'll run through now. Okay, Venn diagram here, as you can see, it shows the probabilities of customers having various combinations of a starter, main course or dessert at Polly's restaurant. And we've got S is the event, a customer has a starter, M is the event, a customer has a main course, and D is the event, a customer has a dessert. So they're given here those probabilities, and they're generally filled in except for the value P and the value of Q. Now we're told that the events S and D are statistically independent, and your job is to find the value of P. Okay? So away you go. If you haven't started already, find that value of P. This is an important point here, that S and D are statistically independent. You're going to need that concept in order to work out A. I'll drop you a hint in a few moments if you don't know what that about statistically independent is, but it will give others a chance just to move on. Just seeing a few notes coming by on the previous question. We used to use tables. A lot of my video tutorials have got tables in. If you want to check those on ExamSolutions.net. I've also got a few examples that use the calculator now. Okay, it's great to be able to use the calculator a lot faster on normal distribution, and for that matter, the binomial and Poisson distributions. Okay, so I said I'll give you a hint about independent events. You're going to need this result here. If S and D are independent, the probability of S intersected with D is equal to the probability of S times the probability of D. Okay, independent events. Okay, so we're looking for that value of P. Okay, using this result here. Anybody getting close? Just put your answer in if you feel that you've got that answer for P. Have a go. Okay, we're getting some answers coming through. Okay, I'm not saying who's got it right, if any of you have got it right at the moment. Just nice to see you having a go. I'll give you a clue. It is an exact answer. You can write it down as an exact fraction. Okay, let's give you just a few more seconds to have a go. Anybody else want to type in their answers? Okay, only a few takers on this one by the looks of it. Okay, well, I'm going to have to give you the answer. Only one of you has got it right. And it is Jimbo. Okay, well done, Jimbo. Okay, you are right. Let's take you through this. Okay, what you've got to work out first of all is the probability of, say, getting S. I'm going to work out the probability of getting S. That's the sum of these probabilities in here. Equation. Okay. I want to work out the probability of D, which is the sum of all these probabilities. I'm going to look at the intersection, the sum of these two probabilities, and form an equation. and solve it for P. So here we go. This is what the probability of S is going to be. It's going to be the sum of these probabilities in here. P plus the 0.04 plus the 0.10 plus the 0.17. Tidy that up, you get P plus 0.31. When it comes to the probability of D, you're just going to need to sum up these 4 probabilities in D, okay? And that comes to 0.35. When it comes to the intersection of S and D, that's these 2 probabilities, 0.04 and 0.10. You should have that result in, comes to 0.14. So all I need to do is substitute these values into our equation, which I'll call, okay, up here. And if you sub them in, you're going to get this equation. Just multiply it out by 0.35, rearrange it, and you should find that you get P to be 0.09. So well done to Jimbo for getting that one. And I see Raja has also put up 0.09. Okay, so do remember you can come back and look over these on the replay, okay? Once the live stream finishes, give it a few moments and it will be up online so you can play it back to any part of the video, okay? Right, let's move swiftly on, okay, because time is precious. The next part, part B, okay, is going to appear here. Now, I've written back the value of P, 0.09. So for 2 marks now, very short question. Hence, find the value of Q. Hence by the way, remember what hence means? Okay, find the value of Q. So just put up your value of Q as soon as you've found it. Shouldn't take too long. Okay, Rahima storms in. 0.39. What about anybody else? Is it 0.39? We had a lot of mistakes on the last one. Abby, 0.39, I see. Anybody disagree? Or is it 0.39? Yep, 0.39 it is. Well done. A lot easier than the last one, okay? All you've got to remember is the sum of the probabilities in this Venn diagram has got to total 1. So, all you've got to do is remember that, and then you know the value of P here, 0. So it's a simple case of Q is going to equal 1 minus the sum of all these other probabilities, okay? There it is. Do that. Q is 0.39. So well done, guys, for doing that. And it was Rahima this time coming in with the correct answer, first of all. Well done. And well done to you other guys out there who've had a go. All right. We've got another part here. C part 1, okay? There's another part after this, part 2. Question here is worth 4 marks. You've got to find the probability of D given, that's what that vertical line is, M intersected with S, okay? Work out that probability here. So I'm looking for an exact fraction would be really good, okay? An exact fraction rather than the decimal. So see if you can give me that probability. The probability of D given that M and S, or M intersection S, has occurred. Conditional probability here. Okay, we're getting an answer coming in. Khadija, I hope I got that right. Khadija, coming in with 35 over 27. Marcus with 10 over 27. Jimbo with 10 over 27. Differing answers out there. 10 over 27 coming in now from a lot of you guys. Well done. It is 10 over 27. Very easy to get when you're dealing with Venn diagrams. Okay, let's show you how it's done. You're given that M intersection S has occurred. So when we look on the Venn diagram, M intersection S is these two regions here, which has a total probability of 0.17 plus 0.10, okay? 0.27 is that denominator there. Well, sorry, not denominator, that value. It will appear as the denominator, as you'll see in a minute. The probability, though, that D has occurred, given that these two events have occurred. When we look at D, we can see that in these two events, D occurring is just this region here, okay? 0.0 compared with, or out of, divided by, in other words, the sum of 0.10 and 0.17. If you do that sum, that's what you're going to get, okay? And it does come out exactly as 10 over 27, or as a decimal, 0.370 occurring with the dots over the 3 and the 0. Okay, that's what you see on your calculator up here. 0.370, 370, 370 and so on. Okay, right, that's that one. That gives you a clue now how to do this next one. Here it is, part 2. Very similar idea. The probability of D given M and not S. Okay, M and not S. There's a little prime there or dash there against that S, just in case you can't see it. Okay, have a go at that one. Put up your answer as soon as you can, alright? Give us as a fraction if you can, an exact fraction. Okay, Jimbo's coming in with an answer. Anybody else out there? Gonna put in an answer. Khadija has got an answer. Got a couple of 5/18ths here. Is it 5/18ths, I wonder? Or is anybody going to give us up another answer? 5/18ths, Rahima. Okay, guys, we're going to rush on here. It is 5/18ths. Well done to you guys out there. Let's show you how it's done. Again, with Venn diagrams on conditional probability. Very easy. Okay. Let's just go through it. M and not S has occurred. We're given that has occurred. So let's have a look at M and not S. You're not in S, but you're in M, okay? That has to be this region here of 0.15. We know that that has occurred. Now, what's the probability that D has occurred, okay? So, the probability that D has occurred, given that we know this has occurred, okay, is going to be sorry, let me just start again. We know M and not S has occurred, okay? M and not S. That's these two regions, okay? Beg your pardon. Q and 0.15, okay? M and not S. We worked out Q as being 0.39 from part B. So that forms our denominator. What's the probability that D has occurred out of these two? Well, that is this part, 0.15. That's the part of D that has occurred given these two have occurred. Okay? So when you work out that fraction, you should have this result. 0.15 Okay, that's that bit. The probability that D has occurred, given that these two results occurred, M and not S. Okay, so work that out and you will get the 5/18 or 0.27 recurring. Okay, right. Let's quickly move on. Okay, so we'll do this last question now. Hope you got that. Don't forget you can come back and replay this video afterwards, after it's live streamed. It will be out there. Right, the last question now is on permutations. All right, somebody asked me the other day, can I put up some permutations questions? So we're going to make a start on this one. Find the number of ways in which all 9 letters of the word Tennessee can be arranged if all the letters of E are together, for 3 marks. Okay, so these can be quite tricky questions. So just go for that one. Tell me how many ways. Just type in your answer when you feel that you've done it. Don't forget, next week Michael's going to be doing some live streams Monday, Wednesday and Friday for GCSE students. So brothers and sisters out there, or even yourself, you want to see Michael do a presentation, do come back on. I'll be doing presentations on the Tuesday and the Thursday. Tomorrow, Friday, I'll be doing a pure maths presentation. Okay, 10 o'clock, usual time. Okay, I see some of you guys coming in with 6 as an answer. Okay, have a look, just think about it. Okay, anybody else? Okay. So this is taking longer than I thought to get here. Okay, I hope you guys are okay with this. Normally I try and get these tutorials and workouts to be about 30 to 40 minutes long. We're getting close to 40 minutes. Okay, we've got one more after this. Okay, we've got Jimbo coming in with 2,160. Okay. Any other answers at all? Or has Jimbo got it correct? Din with 18. So we've got a couple of different answers. Okay. Okay, Sean with 180. How are we doing? Okay. I always think these questions, these kind of questions, are very hard to put down on paper from showing working, shall we say, okay, your thoughts, especially for examiners to see. So you'll see in a minute that I've put down some extra bits in to help hopefully guide you through. Okay, right, well, I don't know whether I've got any other takers out there. Is there a right answer out there? Well, the answer is, and Din, it is 180, as I see you've just put up. I have to give it to Sean though, okay, unless maybe Din you just mistyped there. Okay, it is 180. So let's quickly show you how this is done. I've reorganized my letters here, that's up to you. I've grouped them up, something like this, okay? And then when we're dealing with items that must stay together, I tend to package these up. I put a circle around them so I can object. I'm thinking these as objects, okay? Now, some of these objects look the same at the moment. The N's look the same. The S's look the same. The E's, although they're the same, I've packaged them up as one. They're going to stick together, so I can just see those as one item. Put subscripts on the N's and the S's, okay? I've called them M1, N2 in green, as you'll see why in a moment, and S1, S2 in blue. So I can distinguish the difference between them, okay, now. So when it comes to working out the number of arrangements, there are, okay, basically, if I take them as all being different, there are 1, 2, 3, 4, 5, 6 different items, and we should know that the number of ways arranging n items, okay, where order matters, is factorial n. So if you've got 6 items here, then the number of arrangements will be 6 factorial. But it doesn't end there. They're not all different, okay? In any of these arrangements, I could arrange the n's, for instance, amongst themselves 2 factorial ways. 2 factorial, by the way, is 2 times 1. 6 factorial, by the way, is 6 times 5 times 4 times 3 times 2 times 1. Okay? So the n's can rearrange themselves 2 factorial ways. So I need to divide by 2 factorial. Okay? And similarly, in any of these arrangements, we're going to reduce that because the s's can rearrange themselves amongst themselves 2 factorial ways, a total of 2 ways. Okay, so I need to divide that by 2 factorial. That's the number of ways the s's can be arranged amongst themselves. And that's it. Okay, in any of these, those e's are packaged together and they can be moved around. Okay, so work that out, you get 180. So well done, okay, if any of you got that. Okay, so last question. Okay, let's move on swiftly. Last question. This time we've got, if the T is at one end and there is an S at the other end, okay, how many ways are there of arranging the letters in the word Tennessee? Okay, if the T is at one end and there is S at the other end, for 3 marks. Okay, have a go at that. Just let us know what your answer is. Okay, this part of statistics, often called, I see Your Majesty is written in, this part of statistics often referred to as permutations and combinations. Okay, again, check out this stuff, okay, in more detail if you want on my website, ExamSolutions.net. Just look under permutations, combinations in the statistics section. You should find plenty of stuff there, okay, along with more examination questions and practice. Okay, how are we doing? Jimbo with 105. Okay, let's have some other answers. Does anybody agree with Jimbo? 210 for Sean. That's twice as much as Jimbo. Okay, Din with 105. Okay, right, let's zoom on, okay, because time is precious here. Okay, I'm sorry to rush you guys. Right, we're going to set this up. The answer is, by the way, 210. So well done for Sean getting that one correct first. Okay, let's show you how it's done. I've just drawn a quick diagram here with my T and S at the ends. Okay, and if I put T and S at the end, we've got 1, 2, 3, 4, 5, 6, 7 other letters to put in those positions. So when it comes to the number of arrangements, okay, let's just look at letters at the end. You can put a T here, an S at the end here. You could put an S at the front here and a T at the back there. There's going to be 2 ways of doing that. Putting a T at the front or at the end. Okay, T and S at the ends. Okay, there's 2 ways there. Okay, now we've got 7 letters left. Okay, so 7 letters left, that means that there's got to be 7 factorial ways of putting those letters in these middle, in between the T and S, okay? So that'll be 7 factorial. But remember that those letters that you place in here, okay, are going to be those N's. And those N's are going to reduce this answer here by a factor of 2 factorial, because they can rearrange themselves amongst themselves 2 factorial ways, okay? So we've got to divide by 2 factorial. There's going to be 1 S in here, okay? But we don't need to take that into account, okay? It's already been taken into account. It's these E's that we need to worry about, okay? There's going to be 4 E's somewhere in here, and we're not going to be able to distinguish the difference when they are arranged amongst themselves. And they can arrange them amongst themselves 4 factorial ways, okay? So we need to divide by that 4 factorial. And that's it, okay? That's it. It's going to be equal to 210, okay? So, well done then if you got that, okay? So, very tricky, and there we go. All right, so it's now coming up to 10 to 11. So, sorry it's taken so long to get through that lot, but I hope you did understand what I tried to put across there, got some value from it. Thank you, Michael, by the way, for helping out as usual, and Michael from Air Maths Tuition. Thank you guys for sticking with us and showing your support. I mean, I know that there's a lot of other people out there giving video tutorials and live streams, etc. It's great to have your support, and hopefully you'll keep coming back, okay, as we move on. Tomorrow it's the turn of Pure Maths. I'll be doing that live stream. We'll be doing some more mixed questions from exam papers, and I'll try to bring up some good stuff for you that should be of some value. Okay guys, I'm going to be signing off here. And we'll be closing this in about another 15 to 20 seconds. Okay, so I'm signing off for now. Bye for now. Have a good day. See you tomorrow, hopefully.